Okay, guys, so any questions regarding what I posted last time in this example 11, where we are trying to find the acceleration of the rider basically at some time t is equal to 5 seconds. But before we do that, I have a simple question for you guys. All right, and the question is as follows. So if I gave you, like a trajectory, basically, like a road, right? Think of this as like, you're looking at Google Maps, right? And you have, X and Y, and your path basically is given to you as a function of X, right? Could you tell me, what would you expect for, if a car is traveling with some velocity, right? And then it actually has a velocity, v as a function of time, v of t like that. How can you find the acceleration of a rider inside that car, right? And I'm interested in actually finding the acceleration of the person because ultimately I'm interested in finding the forces that that person is subject to. Can someone tell me how I can find his acceleration?
Isn't it acceleration with two components, AT and AN?
Bravo, right, yes.
Following the velocity vector and one the curvature.
Exactly. So we have the acceleration, right? We'll have
tangential velocity is the derivative of.
Okay, so let's do step by step. So first of all, so we're going to have a tangential, right? So the tangential component here is going to be tangent to the curve, right? So we're going to have this guy is my AT, right? And my AT is actually equal to simply dv dt, right? The v scalar here, basically. I'm simply differentiating that velocity as a function of time. And the other component is going to be equal to what?
V squared over R.
V squared over R, exactly. So you're looking at the instantaneous velocity. So this acceleration here is equal to V squared over R. Okay. Now let me kind of redraw another one, but make it a little bit more elaborative in a sense. Okay, let me just do it here. So let's say I have this guy, and then it's like that. Okay. Okay. Can someone tell me how would the acceleration look like here? Let's say the car is actually traveling with a constant velocity. What would be the acceleration here, here, and then here? And I'm going to label them point A, B, and then C.
Perpendicular to the velocity. If the velocity is constant, so AT equals 0, right?
Exactly. AT is going to be equal to 0. Exactly. So this is going to be my AN, right? V squared over R. But what is the value for R here? What is R here?
Circle.
Radius,
at
right?
this point.
Radius,
yes,
so it's the radius of curvature at this point. So you're going to get x of A, right? So let's say this is XA, and then this is XB, and then this guy is XC, right? You're going to find the radius of the circle at this point. So essentially, at every point in that circle, it's actually possible to fit a circle, right? So I should be able to basically draw a circle or like that, right? And then it's going to have a center, and then this is going to be array. What, so it's not x at the center of the circle, right? It's simply xa is what you use to actually find the radius at A. And do you guys know the equation that we can use to find R in this case? What equation do we use? This equation, right?
Isn't it the one that has the derivative?
So the radius is going to be, so the radius is going to be given by this equation. Singular connection is breaking up dy over dx, and this guy is square 3 over 2 divided by d2y dx squared. Okay, so if I gave you this guy, if I gave you y as a function of x, and sometimes let's say you're, let's say you ended up like designing like racetracks, right? You can always fit, right? Or basically polyfit a polynomial inside data points, right? And then you can obtain y as a function of x, and then you can use that to be able to find the radius of curvature and kind of estimate the acceleration that the race car is going to be subject to. Okay, how about the acceleration at point B? Can someone tell me how would it look like? Is it going to be toward this circle or that circle? Can someone tell me what would be the acceleration of this point? How would AN look like on this point?
Doesn't it depend on the velocity vector, which way it's facing?
Well, the velocity vector will always be along what?
The tangent.
The tangent basically, or the path, right? So we know the velocity will always look like that, right? You guys agree?
Doctor, isn't R big? We can't find AN right here.
If R is huge, what would be the normal acceleration?
Zero.
It would be zero, right? Okay. So those of you who are, kind of good in math will recognize that this point B is called what? An inflection point, right? This is an inflection point, and the second derivative of the curve will become what? Zero, exactly. So at the inflection point, always your second derivative becomes zero. What happened to the radius of curvature?
Infinity.
Okay.
Infinity.
Exactly. What happens to AN?
Zero.
So at the inflection point, basically your second derivative would be zero, and then the radius would be so large that your normal acceleration is going to be zero. Okay, how about the acceleration at this point, right? So how about the acceleration at this point? So this is, is it like this or like that? Which one? Is it like this?
The second one.
You mean this guy?
No, the upwards.
Okay, why is it the upper one? It's because it's pointing toward the center of the circle, okay? So always your normal acceleration will be pointing toward the center of the circle. Okay, this is what I wanted to cover. Like this is basically just conceptual, just to make sure that we are all on the same page. So make sure you are familiar with that, you're understanding what is actually going on here, and let us actually jump into this prep. Okay, so example 11, I'm going to actually repeat that example just so we are all clear on it. Okay, so we have this motorcycle that is traveling on a ramp, and then maybe it's trying to jump, right? And then it's going at it's traveling at 1 meter per second when it is at A.
But doctor, can I ask something?
Yeah, sure.
Why don't we have a tangential acceleration in the previous graph?
Yeah, we said the car is traveling at a constant velocity, right? I said the car is traveling at a constant velocity around this.
Okay.
Okay. So you have no tangential acceleration because you have a constant velocity, but you have normal acceleration. Okay. Okay, awesome. So example 11, we have this motorcycle that is traveling at 1 meter per second at A, right? So we know V0 is equal to how much? 1, مظبوط, 1 meter per second, right? And then this V0 is basically at A. We would like to find, okay, and then I tell you that this motorcycle is, the velocity is increased at V prime is equal to 0.1 meter per second square. So 0.1 meter per second square is nothing but the acceleration, right? Because it has the same unit as acceleration, and we know that this is V prime, so it's basically acceleration, okay? So we know the acceleration in this case is constant, and then the acceleration is equal to 0.1 meter per second square. And we would like to find the speed and the acceleration when t is equal to 5 seconds, okay? So what I would like to do is, so here, this is 80, right? You guys agree that this is 80 because they tell me that the speed is increased, right? If the speed is increased, basically you're simply getting the acceleration along the curve, right? Which is 80. We're not here knowing the overall acceleration as an acceleration vector, right? We said A is equal to AT UT plus AN u, and here they gave you at, but there are another component of the acceleration, which is an, that is caused by the fact that the velocity vector is changing direction along the motion. Okay, so we're trying to find, so this guy starts here, right? And it kind of follows a parabola. And at some time here where t is equal to 5 seconds, I would like you guys to find me my at and then an. So can someone help me out? What would be at at 5 seconds?
Same, 0.1.
Bravo, exactly. So it's not going to change, right? So at is going to be equal to 0.1 meter per second squared. How about an?
We should
V square
calculate
over R.
V squared. What V? Is it V0 squared?
No, VT5, V at T equals 5.
Exactly. So it's going to be V at 5. So we're going to index it like that, right? So V of 5 divided by what? Radius, right? Of this point, right? And let's call this point XF, مش هيك? So the radius is a function of the position, right? Okay, or I could okay, this is square. So V at 5 squared divided by, let's just call it R squared, okay? So we know what R is. R is basically, we should be able to basically kind of like, you know, curve fit a circle, which would kind of look like that, right? And then it's going to have this radius. Okay, all clear? Okay, so how can I find, so I need to know V of 5, and I also need to know R at 5 seconds. So how can I find the velocity after 5 seconds?
We integrate A of T and we replace.
Exactly, we're going to integrate A of T, right? So what is the integration of 0.1?
0.1 T plus V0.
Plus V0, which is 1, okay? So V of 5 is going to be equal to how much? 0.1, right? Times 5 plus 1.
1.5.
Which is equal to how much? Okay, 1.5 meters per second. Thank you so much. Okay, so we find the velocity. Now we still need to find the radius. How can I find the radius of curvature?
We need x.
Okay, we need x. How do we calculate x?
We can find the S and from S find X.
Okay, very good. How can I find s?
Integrating the velocity, right?
Integrating the velocity, exactly. So when you integrate the velocity, you're going to find the distance along the path, right? So s of t is going to, okay, all right. So s of t is going to be equal to the integration of v of t dt, right? Plus s of 0. مظبوط. S of 0 is 0 because I'm starting here in the origin. Okay, you can still see that. What would be the integration of that? So it's going to be 0.1 t squared over 2 plus t, right? So we're trying to find S of
بس دكتور انا معي الايكويشن تبع الواي، ما فيني اعمل ديريفيتيف ودبل ديريفيتيف حتى اطلع الار.
بس ما دبل ديريفيتيف بتصير 0 بتصير انفينيتي.
No, wait. Okay, so you said you have the equation of the curve, right?
Yes.
Okay, this is y as a function of x. This tells you nothing about the velocity. Okay, this is like you're looking at the road, right? Can you tell the velocity from the road? If you have a road, basically you could be going at any velocity with any acceleration along this road, right? Okay, your velocity and acceleration you're going to tell it from your initial conditions and whatever that we have here as inputs to the motion. So input to the motion is you have the velocity is 1 meter per second, and we have the acceleration of the motion is that. So we're going to use this to find the distance along the curve, right? Y as a function of x here is simply defining the shape of the path, right?
مش عم نطلع radius of curvature ها؟
Yes, exactly, but we're extracting the radius of curvature at its position x, right? So we need to know x basically to be able to get that radius. How do we know x basically? There's no way for us to know x because x can depend on how fast you are going. So at t is equal to 1 second, you're here.
يعني ما خص
yeah, exactly.
y equal 0.5
square.
Exactly, yes. You will only need that to be able to get the radius of curvature, right? But this would be a very generic radius of curvature. You need to know at what point on this road you are trying to get the radius of curvature, right? And for us, based on what we have, the motion will define where we are along the motion. And then we have to think of another way. Once we actually have S, we have to look into another way to be able to kind of see, okay, if I'm here on the curve, what would be my X, for example, right? And you know, take it from that. So okay, let's find S of 5 seconds. So let's see how much we have traveled along the curve, right? How much can we tell? So let's plug that in here, right? So it's going to be 0.1 times 5 squared, which is 25. Divide that by 2 plus 5. Is that true or no? I think that's true, right? We have our velocity. We integrated the velocity, right? Okay, so it's all good. So 25 over 2 is 12.5, right? 12.5 times 0.5 is how much? 1.25.
Dr. Honey, S represents what? Yes.
Okay, S represents what? You see it on the figure, right? S is the distance along the curve, like how much you have traveled along the actual parabola.
Okay, doctor. Thanks.
Okay. Okay, so هلا we know basically we have traveled 6.25 along the curve, right? Basically at t is equal to 5 seconds, basically we have one, you know, like 1 meter, 2 meter, 3 meter, 4 meter, 5 meter, 6 meter, 0.25. How can I find X? Did anyone think about it during the weekend or no? Honestly, I was gonna give whoever that knows it basically 5 points on your first midterm, basically. But I'm not sure if anyone, you know, thought about it.
دكتور نحسب اللاين اللي بتقص الارك بين تي وفي 0 البوينت الاساسي.
No. Okay, so next time, guys, try to, like, you know, do that extra step, and it will help you, you know, as an engineer in the long run. You know what I'm saying? And also, usually I give you guys like credit if you actually know how to do that. Okay, so here's
find Y and then we replace.
We find Y, but you can't find Y because you have S basically. مظبوط? Literally, all that you have here is we have this guy, right? All that I gave you is 0.5x squared. مظبوط? And here basically, okay, so here's what, okay? So if you have any curve, all right? If you have any curve, you have dx, you have x, then you have y. If you take a very small element on the curve, basically, okay, I can basically separate that element into dx, مظبوط, and dy, okay? And this guy is gonna be what? ds. You guys agree?
Yes.
Okay, can someone tell me how ds is related to dx and dy?
هون لانه عم ناخذ فيري سمول سامبل بتكون كانها تريانجل في اعتبر انه دي اس ستريت لاين يعني ما في اعتبرها كيرف.
ds مش the slope.
Exactly. So it's a very small element. Then I can consider ds to be a straight line.
Straight line. يعني دي اس سكويرد equal دي اكس سكويرد بلس دي واي سكويرد.
Bravo. Exactly.
وبعمل لها integral.
Okay, how can I integrate that? It's already square.
Yeah.
How can you integrate that?
في اعمل دي اكس سكويرد اوفر دي اس بلس دي واي سكويرد اوفر دي اس.
اوكي دي اس ليش ما بنعمل هيك مثلا؟
او بالقلب او دي اس سكويرد اوفر دي اكس.
ليه ما نعمل هيك مثلا؟
اوكي
اوكي طيب هلا اوكي how can I ultimately from here, right, I know dy over dx, مظبوط. So somehow I want to be able to put that as a dy over dx. Okay, what next? Maybe I can do this, right? If I can divide by dx squared.
dx common. صح dx common.
dy over dx squared, right? And then here, so this is multiplied by dx squared هون مظبوط. So literally divide by dx squared, right? صار عندي هون dx squared. if اطلعها برات square root شو بتصير؟ بتصير dx. مظبوط؟
مش arc length هيدي.
Do you guys agree how I'm coming from here to here? Do you guys understand these steps?
Yes.
Okay. All right.
Yes. dy by dx is x.
dy over dx, exactly. So dy over dx is simply 2 times 0.5 is 1, right? So square root of 1 plus x squared. Okay. All right. So Anna, what do I have? And I have s. I don't have ds. So what should I do here?
Integral.
Integral. Okay. So you're gonna integrate this guy from 0 to how much?
S. أو S. فين أحط 5 يعني؟
6.25.
Sorry, 6.25. Sorry, 6.25.
Then from here, I'm gonna put 0, and then I'm gonna put what?
X.
The x that I'm trying to find, basically, right?
Yes.
Okay, so integration of this guy is simply 6.25. Okay, I'm gonna come back to this. Okay, I'm back to this, and I'm gonna rewrite that. So basically, I'm integrating 0 to xf. Square root of 1 plus x squared dx is equal to 6.25. Now I need to integrate this guy. Okay. How do you integrate this guy? Okay. What I want to introduce you guys today is I'm going to introduce you guys to MATLAB. Is anyone familiar with MATLAB?
شو الوضع؟
Yeah. I'm not familiar with it, doctor, but I know it. Yeah, it's like a coding.
Okay, so if you are trying to integrate this guy, you have to use basically, trigonometry, right? And I'm not going to ask you to do that, but I'm just going to introduce you MATLAB today a little bit. What you guys should do is you should try and download MATLAB just for your own. In this course, I'm not going to ask you guys to know MATLAB, etc. But I think it's very valuable that you guys learn MATLAB, and then that is why I'm going to introduce that, very briefly today, and then how you can do stuff on it, right? So MATLAB is like a calculator. Right? I can do like A is equal to 1, B is equal to 2. I can do A plus B, all right? So it will simply do that. So what I'll do is I'm just going to integrate this function, right? Integrated basically will define, we have the symbolic variable, which is x. I'm going to do that. And I can simply integrate that, right? Integration of square root of 1 plus x squared. Okay, so I can integrate that, and then this is my answer. You would literally have to integrate that. And once you integrate that, you're going to get to this value, مظبوط. So essentially, so this is called a sinh function. And now this is beyond the course, okay? So don't worry about this. I'm just going to show you how you do this. X over 2.
Doctor, نحن we are allowed to use integral calculators نعمل integrals.
Yes, you are allowed to use integral calculators, yes.
Okay, thanks.
Plus xf, right? Multiplied by xf squared plus 1. And then this.
قال لي ما معه integral calculator شو بيعمل؟
There is no need to actually, I'm not going to ask you on the exam to actually do that. And then this is, you can't even solve this problem.
Okay.
So if you actually do this integration, you're going to end up with something like that. And ultimately, this is a nonlinear problem, right? This is not like a linear problem, like, xf plus 5 is equal to 10 or whatever, right? If you do this, you have to use a nonlinear problem, nonlinear solver, basically. And obviously, I'm not going to ask you guys to do that. So here, basically, you would simply obtain xf, and then let's say we know what xf is. Okay, let me just do that. Let's say you were able to actually solve that. I'm not gonna, solve that numerically for you guys. I'm not sure why they actually gave you this as an example. Let's say you have xf. Now, what you do next is you're gonna find the radius of curvature, right? I'm gonna stop sharing now, and then I'm gonna come back to my lecture. Okay, so let's say we have xf. We solved this problem, and then we obtained xf. Now, how can I find A? We're going to find our radius of curvature, مظبوط? This guy, right?
Yes.
Which is dy over dx squared And this guy over 2 divided by 2 divided dx squared. Okay, how can I find rho or the radius of curvature? What is dy over dx squared?
We derive the function. It's
The second part.
0.5 times 2x.
Which is going to be equal to 1. مظبوط? So this guy is equal to 1. We still have this, so rho equal to 1 plus, so dy over dx is equal to x plus x squared. 3 over 2, so rho of xf is equal to 1 plus xf squared 3 over 2. Okay. So this is your radius of curvature. Once you find your radius of curvature, you are going to find your normal acceleration, which is equal to v squared over r. Okay, guys, any more questions on that? Or so this is a problem, and then this is how we solve it. The only step that you guys are not responsible is how we did that, right? So how you integrate this guy, when you integrate this guy, you end up with this guy, right? And here, this function is a nonlinear function, so it's not easy to solve that problem. You will learn that later in your other courses. So if you actually plot this function, you're gonna maybe like end up with something like that, okay? When you are solving this guy, basically, let's say this is 6.25 مظبوط. So this is a line of 6.25. So you could have, one solution, two solutions, three solutions. You can have multiple solutions. Okay, so this would be one solution. Each one basically is a solution, right? So depending on where you are, you're gonna find a different solution. In this problem, probably you will only find one solution. And the other one will be like a complex number, right? Or actually you will find two solutions, right? And it's a parabolic curve, right? So y is equal to 0.5x squared. It will actually have another side to it in a negative x-axis, right? So there are two different x values. So one is positive x and the other one is a negative x value. Any questions, guys, on this?
Clear.
Okay.
أنا
دكتور
عندي
بس
question كبير.
Yeah, sure.
لما طلعت ال radius of curvature استعملت ال y equals 0.5x square.
Yeah.
بس ما استعملت ال equation اللي نحن عم نطلعها.
What do you mean equation اللي احنا عم نطلعها? Which equation are you referring to? This equation?
ما أنا لما سألتك أول شيء إنه ما فيني طلع دغري ال r قلت لي لا. قلت لك ما فيني طلع دغري من 0.5x square قلت لي لا. يعني هل نحن حلينا الانتجرال الكبير رجعنا على الصفر حلينا 0.5x square عملنا derivative مرتين.
Okay, but you need to evaluate this, right? So basically, you see my radius of curvature is a function of xf squared, right? How do you know xf? Right? How do you know xf basically? How do you know the x position of the rider, right, at 5 seconds? How do you know that, right? The only way for you to know the x position of the rider is by, we had to do this integration and then we had to solve it. And here we didn't do the step of actually finding, what xf here would actually give me this because I have this cinch function, which is a nonlinear function, okay? So you need to do this in order to actually obtain that 5 seconds. Okay, guys, so I'm gonna actually solve another problem very quickly and we're gonna wrap it up a little bit soon today. So in example 12, so I can have basically time for, as office hours essentially. So let us actually quickly do example number 12. So here we have another example of a motorcycle running at 40 meters per second initially. So we have our V0 is equal to how much? 40 meters per second. And they tell us that the acceleration, which is V prime, A, is equal to minus 0.05 times s. So it looks like the acceleration is a function of the position here, okay? We would like to find the speed and acceleration of the motorcycle at point B, okay? So we're trying to find the velocity of the motorcycle at point B. How can I find that? So let's say this guy is actually doing, it's kind of doing like a quarter of it, like a part of a circle, right? And its angle is changing by 60 degrees during that movement. And this is point A, this is point B. The radius is 150 meters. 150 meters, not degrees. Okay, any thoughts on this? I need to find VB, right? So
شنو على الانتجرال؟
VA is
طبعا
equal to how much? The initial velocity هون هي 40 meters per second. What would be the velocity at B?
integral of the acceleration.
Okay. What do you mean by the integral of the acceleration? And how? You mean هيك?
هي A ds is equal to V dv.
You mean like this?
No, A ds is equal to V dv.
Okay, how come this won't work? And now I'm gonna actually ask some people here on my chat, the participants basically. Let me ask. Let me see. Peter Khalaf. Peter, can you help us out? We're trying to see how do you find the velocity at this point, given that you have this acceleration. How come this won't work? Can you tell us, Peter?
Because the acceleration is in a round movement.
ما سمعت.
The acceleration here.
Acceleration.
الموفمنت اللي عم بيكون acceleration فيها بيكون غير ما بتزبط عليه الانتجرال.
Can we talk in English when you're explaining stuff?
Yes, because we have like a circular movement.
Okay.
So we can do this. We can do the integral of the acceleration here.
If you have a circular movement, you can't do the integration of the acceleration.
We need to use the angle على دي ار الانتجرال تبع دي ار.
No, not necessarily. Yeah, you can always, if you have the acceleration, you can always use, you can always integrate the velocity. I don't see why. Let me ask another person, if possible. We'll tell you the answer soon, hopefully. Let me ask another person. I'm gonna ask.
Doctor?
Just wait a second. Let me just ask.
Okay.
Ask Ronaldo Al-Asmar.
Yes, doctor.
Yeah, can you tell us, like, can I use this? Can I use the velocity? Can I integrate the acceleration with respect to time?
No, because here we have velocity عندها التنجنشنال والنورمال acceleration. فلأنها circular عندها radius of curvature. أو لا.
No, that's also not.
لأنه A equal to AT plus AN.
Okay, wait. I'm not asking you about normal acceleration right now. I'm not asking you about any of that, right? I'm simply telling you that you have this motorcycle, right? It's traveling along this arc. Its initial velocity is 40 meters per second, and I'm trying to find its velocity at B. So I don't see how the normal acceleration will actually influence the velocity, right?
Oh, I don't know.
Okay, let me ask Samir.
Yes, doctor.
Yes, Samir, can you tell us how can I find the velocity at point B?
Doctor, if we want to integrate the acceleration, shouldn't it be in terms of time?
Yeah, but unfortunately, they didn't give us acceleration as a function of time. So how can I convert this acceleration to make it a function of time?
Before
How?
there's a formula. لا.
Okay, who's speaking? Okay, Angela, right? You.
Yes.
Okay, guys, I told you guys, when you have the acceleration as a function of, and by the way, this is AT, this is not AN, this is AT, okay? The speed is increased, is decreased, or the speed is changing at that rate. So this is AT, right? So every time, guys, you have the acceleration is given to you as a function of the position, not time, position. When the acceleration is given to you as a function of the position, you should just use ADS is equal to VDV, right?
Yes.
And then you integrate that. Okay, so if A is given to you as a function of S, then you can integrate that, right? And here, what would be the boundaries for the integration?
0s.
So you're going to integrate that from 0 to S, okay. And then how about the velocity?
From 40 to V.
From 40 to, let's call it VB, right?
Yes.
So now, because A is given to me as a function of S, I can now integrate that because I have this differential element ds, right? So it would be minus 0.05 S ds from 0 to S, right? Or mainly, that's actually SB, right? Is going to be equal to V squared over 2, 42 VB, okay? What is the integration of this guy? Going to be minus 0.05 S squared over 2, 0 to SP is equal to VB squared over 2 minus 40 squared over 2. And what is SB in that case? What is
Pi
SB?
over 3 times 150.
Exactly. So you're going to multiply this in radian, right? Can't be 60 degrees. It has to be in radian. So pi over 3 times how much? 150 mazboot. So now we actually get the length of the arc. Pi over 3 times 150. So this is S squared, and then you divide this guy by 2. That's going to be equal to VB squared over 2 minus 40 squared over 2. So now I can basically solve what VB squared is. Might be a good idea to multiply the whole thing by 2, right? So ultimately, you're going to end up with VB is going to be equal to square root of 40 squared plus 0.5 pi over 3, 150 squared. So this is your velocity at B. Okay, and that really sums it up with...
Minus.
Yeah, that is minus, exactly. Okay. This guy becomes minus, and if you were to actually find the acceleration at B, right? In that case, you're gonna have square root of AT squared plus AN squared, right? What is AT? AT is given to me directly as a function of the position, right? So AT is gonna be minus 0.05 times S. What is S? S is gonna be equal to pi over 3 times 150. Mazboot, because acceleration is already given to me as a function of the position, so I can directly find AT. And if I want to find AN, is going to be equal to how much? I need to find VB squared. So after you evaluate that, so it's going to be VB squared over R. You have these two values, you plug them here, and you can find your actual magnitude of the acceleration at point B. Okay, guys, so this sums up this lecture. And now our meeting is going to end, so I'm going to close this, and then I'm going to open it up now for kind of like office hours and questions about what we just have. So if you still have more questions, then just log back in to this meeting. Okay.